Hi, in this video we are going to go over the solution of the problem 582 kill processes, and we are going to use BFS. And for doing that we are given two lists, that is PID, and the first one that shows us the nodes of a tree. For example, this is node 1, 3, 5, 10, and then we have a list of their parents. For example, for node 1 I know the parent is 3, so 1 is related to 3. Second column, 3 is related to nothing, 0, that is the root. 10 is related to 5, 5 is the parent. 5 is related to what? 5 is related to 3. Description is telling us if I kill number 5, if I kill this node, what other nodes should be killed? So if I kill 5, I have to kill 10 as well, because that is a child of 5. Okay. But for example, if I kill 3, I have to kill all of the nodes. Or if I kill 1, I don't need to kill any other node. Likewise for 10. So I don't need to kill any other node. The first thing that we are going to do is to define a dictionary. So I go over this list and try to make this one here. So for example, for number 3, for the key 3, I have a list 1, 5. That shows for node 3, it is related to 1 and 5. For 0, that is here, this parent 0, that is related to the root 3. For 5, that is related to 10. Okay, the next thing that we are going to do is to make a queue. So as you know, we import that from collections, and I'm going to put the first node which is killed as an input to that, and this 0 is going to be our timer. So our queue is this one right now. 3 is 0. For example, for this example, if I kill 3 here, 3 is 0, and we know that is added to the queue. Okay. Then I define a set, call it scene, and I add the kill to that. So now that set has 3. I know that I killed 3. Okay. Then we start a while loop. I say I have this while loop here, and I pop R and T from the queue. 3 and 0. T is for time, and R is the node that we are right now at that. Okay. And then I say if R is part of the keys, so then I go and search around. Is 3 part of the keys? Yes, it is here. So it has children. So I go and search around it. Now I go for neighboring nodes. So now you see why we created that dictionary, because I need the neighborings of R in a nice format. So I can just loop over that. And when I do that, I append that to the queue, and I increase the timer by 1, and I add that to my scene list. So in a case that that is not a part of the keys, so for example, I at the node 10 or 1, a leaf node, that is not part of the keys here. So in that case, I just add that to my scene. So, and at the end, I return the scene and the timer. Okay, let's run a code again. So, and go over that. At the beginning, we had a dictionary like this. So that is showing the relationship of each parent to the children. And then we add that at the initial point, the node that we want to kill, and put the timer 0 and add that to the scene. Now we pop left R0, T0, and when I do that, I go for the neighboring of that. So what is the neighboring of 3? 1 and 5. We also see that in the dictionary, 1 and 5. So when 1 and 5 are the neighborings of that, they will be added to our scene set. So we update the scene to 1, 3, 5. Now we pop left the next one. R equals 1 at timer 1. So what is R equal 1? R equal 1. It doesn't have any children. Okay. The next one, R equals 5 at time 1. So when R equals 5, so it has a children 10. So then we add that to the scene. So now we go for the next one. So for the R equals 10, we pop left, R equals 10 at timer 2. So when we do that, not part of the keys, because that's the leaf node, and when we add that to the scene, that's already in the scene, so it doesn't change anything. So at the end, I have these nodes that need to be killed if I kill number 3. If I kill the root, I have to kill everything. And 2 is our timer, and it takes 2 seconds or timer steps to kill all of the nodes. So you see nodes 1 and 5, so they both were killed at timer 1, and node 10 at timer 2. This is a BFS method, so we start here and then it grows to this level and then it goes to this level. Okay, this is the solution of the problem. Now let's talk about time and space complexity. Time complexity of this problem is order of n because we are visiting each node only once, and space complexity is also order of n because we are creating some variables like dictionary, scene, and also queue, but in a worst case scenario the size of these variables at max be n. So as a result our space complexity is order of n. Okay, this is the solution of the problem 582, and thank you again for watching this video.